Hello everybody. So today we'll be going through the second set of numericals which are on cables or cable segments. So numerical or problems on cables or cable segments. Cables or cable segments. So let us discuss a number of terminologies which are associated with the cables. In order to understand, let me consider a cable arrangement or cable segment. So this is of it goes. Let me consider a small example of cable segment or arrangement in order to understand the terminologies. A, B, C, D, E. Okay. So this is the considered cable arrangement. So cable arrangement has a number of terminologies. A particular cable segment is formed by joining a number of cable segments. A particular cable arrangement is formed by joining a number of cable segments. So AB is the first cable segment or one of the cable segments. BC is the other cable segment. BD is the third cable segment, and DE is the fourth cable segment. So these are the cable segments. So these four are the cable segments. By joining a number of cable segments, you get a particular cable arrangement. So this has 1, 2, 3, and 4 cable segments. 4 cable segments are being joined here. Now, point A, point C, and point E. These three are the supports. Supports. So AB is a segment, BD is a segment, DE is a segment, and BC is a segment. A, C, E are the supports, which are marked in this way usually. Supports. Now, these two, coming to this particular thing in this, these two are the suspended loads. It's not a part of segment. This is not a segment. These are the suspended loads, self-weight or weight which has been hung in order to arrange the cables. These are the suspended loads. Now, the last terminology and the most important terminology is the junction point. The junction point is a point in the cable arrangement, in the entire cable arrangement. Junction point is a point where 2 or more than 2 cable segments come and meet. So, for example, B is a junction point. Agree? So you have AB, BC, and BD. You have 3 cable segments coming and meeting at B. So B is the first junction point here. Even D is a junction point, is it not? You have BD and DE, 2 cable segments coming and meeting at D. So in this particular example, you have 2 junction points, B and D, 2 junction points. Whereas E, C, and A are not junction points. Those are the supports. Hope this is clear. So these are the terminologies which you're supposed to remember. The first terminology is the cable segments. So you have A, B, B, D, D, E, and BC. You have 4 cable segments here. Second terminology is the support. You have 1, 2, 3 supports here which are indicated using this particular sign. And these are the suspended loads. It's not a part of the cable arrangement, or this is not a segment. These are the suspended loads. And finally, the most important terminology is the junction point. Junction point is a point along the cable arrangement where 2 or more than 2 cable segments come and meet. So AB, BD, and BC comes and it meets at the point B. So B is one of the junction points, and even D is the other junction point. So these are the terminologies which you are supposed to remember. Out of these terminologies, we are not interested in supports. We don't consider supports. We're nowhere. or anywhere. We don't consider supports. We are not at all interested in supports. You can eliminate it. It's enough if you just identify or differentiate supports and junction points. If you understand which is a junction point and which is a support, you are not interested in support, so let us leave it. Now, cable segments and junction points and suspended loads are the three terminologies which you're supposed to understand and remember. Understand and remember. Now you have a number of steps here to follow. In order to solve the problems related to cable segments. Let me explain all the steps in detail. Let me draw the example once again in order to go through the steps. Let me consider another cable arrangement. Just an example this is. So this is A, B, C, and D. A, B, C, and D. Now, step number one. Again, let me tell you before we go through the steps. Here, all the problems related to cable segments will be related to finding the unknown force or finding the force which runs through the cable segments. So you'll be ultimately finding the force which runs through all the cable segments. You are interested in this. So finally, you'll be finding what? You'll be finding the force which runs through the cable segment. So usually, force which runs through all the cable segments will be considered as tension. We call it as tension. Force which runs through the cable segments will always be considered as tension. Or your ultimate aim will be finding tension which runs through all of these cable segments or all the cable segments. So finally, you'll be finding this. This will be your ultimate aim. Tension which runs through all the cable segments. In order to find the tension which runs through all the cable segments, you have a number of steps to be followed. Let us go through all the steps in detail. So step number one is to identify the junction points. How many junction points we have here? B is the first junction point and C is the second junction point. There are only two junction points. A and D are the supports. We are not interested in supports. So B and C are the two junction points what we have. B and C are the two junction points. Now, once you identify the junction points, step number 2 is to draw the coordinates. Draw the coordinates with respect to the junction points. For example, I have B and C as junction points. Yes, I have to draw the coordinates with respect to B and C. So this will be the x-axis. This will be the x-axis. This will be the y-axis. And the coordinates with respect to junction C. Yes, and y. Drawing the coordinates. This is step number 2. Step number 2 will be drawing the coordinates with respect to the junction points. In step number 1, you'll identify the junction points. And in step number 2, you'll draw the coordinates with respect to the junction. So once you draw the coordinates with respect to the junction points, you will mark the tension which runs through all the cable segments. Step number 3 is to mark the tension T, which runs through all the cable segments. And this is how you mark. There is a rule to mark the tension along the cable segments. See, tension along all the cable segments will always move away from the junction point. So tension should be marked in such a way that tension should always move away from the junction point. Away from all the junction points. Let us consider B. BA is the cable segment. So tension will move away from the junction point. So this will be TBA, which moves away from the junction point. Again, BC is the other junction point which has been connected to B. So tension again moves away. So this will be TBC. So we are done with the junction B. Let us concentrate on junction C. Tension will move away from the junction point. This is TCB. Both are same. Again, tension will move away. This will be TCD. These are the two suspended loads. Suspended loads will always move vertically downwards. Suspended loads will always move vertically downwards. So this is how you mark the tension. How to mark the tension? Tension will always move away from the junction. Away from the junction. Tension will always move away from the junction. So once you mark this much, once you mark all the forces, step number 4 is to draw free body diagram. Step number 4 is to draw the free body diagram. How to draw the free body diagram? It again remains same. You don't have several steps to draw the free body diagram here. It's enough if you reproduce only the coordinates and forces which you have marked here systematically. It's enough if you reproduce only the coordinates and forces. Let me reproduce and I'll show you. It's enough if you just reproduce only the coordinates and forces without the cables, without the cable arrangement. It's enough if you just reproduce the coordinates. Let me draw the coordinates. This will be the upper one, and let this be the lower coordinates. That. So this is the coordinates associated with the junction point B, and let this be junction point C. Let me connect to B and C. So we have to mark all the forces associated with the junction point B. Junction point B. Observe here. You have suspended load of 10 Newton. Suspended load of 10 Newton. You have TBA. This is TBA. You have TBC. Done. Now come to the junction point C. Observe here. You have 20 Newton suspended load and TCB, which moves in this direction. TCB. And finally, you have TC. As simple as that. Drawing free body diagram is very simple here in all the problems related to cables. In fact, all the problems related to cables are easier than the previous set of numericals. So this will be the free body diagram. This will be the free body diagram. This will be the free body diagram. Once you draw the free body diagram, again you have two free body diagrams here. Again you have two free body diagrams. Again, whenever you have two free body diagrams, you will be selecting the free body diagram with the least number of unknown forces. With least number of unknown forces. Let us go through this now. This has 1 and 2 unknown forces. Let us go through this. Even this has 1 and 2 unknowns. You can consider either of the free body diagrams. Either of the free body diagrams. Consider the free body diagram. After drawing the free body diagram, step number 6 is to consider the free body diagram. Consider the free body diagram. Free body diagram. And if the free body diagram has 3 forces, apply Lami's theorem. Apply Lami's theorem. If it has more than 3 forces, go with the conditions of equilibrium. Conditions of equilibrium. This particular step remains the same as that of the previous one. So after drawing the free body diagram in step number 4, step 4 is to draw the free body diagram. Step number 5 you'll observe the free body diagram which you have drawn. You get 2 free body diagrams. If you have 2 junctions, it depends on the number of junctions. So here you have 2 junctions, B and C, junction B and C. Consider that particular free body diagram with least number of unknowns. If it has 3 forces totally, I'm not speaking about unknowns now. If it has 3 forces totally, you can apply Lami's theorem. If it has more than 3 forces totally, you have to apply the conditions of equilibrium. And finally find the value of T. Finally find the value of tension T, which runs through all the cable segments. So this is how you solve the problems. This is how you solve the numericals related to cable segments. So let us solve a number of problems in the upcoming videos. I will be solving around 2 to 3 problems, example problems in the upcoming videos. Thank you.